Okay, I'm going to give you a nice little consequence of, well, it's not quite a consequence of the rearrangement inequality, but it's a nice way to use it. It's called Chebyshev inequality. Chebyshevs inequality. Sometimes you see it spelled Chebyshevs, different ways of writing it in English, but it's still always pronounced the same. Okay, so what does it say? Well, we've got A1 less than or equal to A2 less than or equal to less than or equal to AN, non-decreasing. And similarly, B1, B2, Bn, less than or equal to Bn, again, non-decreasing. This says that 1 over n, the inequality says 1 over n times a1b1 plus a2b2 plus plus anbn is greater than or equal to 1 over n times a1 plus through an, that, times 1 over n times b1 plus all the way through to bn. So this tells me, if I can abuse notation somewhat, this tells me that if I write A with a sort of tiddles as just the whole sequence through AN, and B underscore equals B1 through BN vectors, then that tells me that A, B bar is greater than or equal to A bar times B bar. Again, it's a non-trivial observation. It's weaker in a sense than the rearrangement inequality, and I'll show you why. But it's a pleasing inequality. Quite often you can, if you in Olympiad questions, quite often the question will say, here's a bunch of numbers. You can put them into increasing order if you want, quite often. And if you can, then you've got access to these inequalities. Okay, well, let's just use the arrangement inequality. Actually, I'm just going to write out something else first through A, N, B, N. That equals A1, B1 plus A2, B2 plus A3, B3, 3 plus A, N, B, N. Now what I'm going to do is I'm going to take, I'm going to swap B2. What I'm going to do is I'm going to apply the rearrangement inequality to B2. I'm going to leave this on its own. So that's the same. Is greater than or equal to A1B2 plus A2B3 plus A3B4 plus plus ANB1. So all I've done is I've taken the A's are in the same place, but the B's have swapped round. That B1 there has gone right to the end, and I've replaced that B1 with a B2. That B2 is now B3, B3 is B4, and so forth. So the left-hand side is still the same. So it's greater than or equal to A1B3 plus A2B, A1B3, A2B4 plus A3B5 plus plus ANB2. There it is, and B1 will be in the second to last place. And I'm going to carry on like that. Greater than or equal to, this is all the way down here, to A1BN. You see I've got A1B1, A1B2, A1B3, and all the way through to A1BN, plus A2, that's going to be B1. So again, I'm multiplying A2 by all the B's in turn, plus A3, and that's going to be B2, plus plus A N B N minus 1, I guess. Okay. So the left-hand side equal, the left-hand side, I'm going to add all these up. I'm going to add all these, guys. I'm going to take a sum. I'm going to add all these. And this sum of the left-hand side equals n times A1, B1 plus all the way through an, bn. What's the right hand side? And we know that the left hand side is going to be greater than or equal to the right hand side. What's the right hand side? I'll write that out again. Right hand side equals, well, I'm going to factorise it. I'm going to say it's a1 times sigma bi plus a2 times sigma bi plus all the way through plus an times sigma bi. That's quite a clever step. What I'm doing here is I am factorising by a1 in column. I could factorise it in rows, I guess, if I wanted, but I'm factorising it by columns. a1, b1, a1, b2, a2, 3. That's this one here. Second column, third column, all the way through. So that equals sigma ai, sigma bi, because I can factorise the sigma bi out. Well, there it is. There it is. So it's basically saying that n times sigma ai bi is greater than or equal to sigma ai sigma bi, and then I can divide throughout by n squared, and 1 over n sigma ai bi greater than or equal to sigma ai over n sigma bi over n, which was to be proved. Chebyshevs inequality. When you say Chebyshevs inequality to any statistician, you immediately think of an inequality about variance of random variables, but I guess this is a perfectly good use of his name. Anyway, I'm going to stop there. Chebyshevs inequality. Stop.